Although it looks it, this footage is not actually real, but is instead CGI to demonstrate a potential future with robots. However, we are not far behind from this piece of fiction turning into reality, as a number of robotics companies around the world have supercharged their investment and activities in developing multi-purpose and increasingly intelligent robots. Today, we will see how one company and its line of robots are leading the charge to make soldiers obsolete. Boston Dynamics is a cutting-edge robotics company, known for its development of advanced robots that are characterized by their impressive mobility, agility, and dexterity. Founded in 1992, Boston Dynamics originally emerged from Massachusetts Institute of Technology, or MIT. Over the years, Boston Dynamics has seen several ownership changes. Notably, it was acquired by Google X, a subsidiary of Alphabet Inc. in 2013, the SoftBank Group in 2017, and finally being sold to Hyundai Motor Group in 2020. Boston Dynamics stands out in the robotics field due to its emphasis on creating robots that can interact with the world dynamically. Their robots often showcase unparalleled balance, agility, and adaptability to varied environments. Boston Dynamics' mission revolves around pushing the boundaries of what robots can do, challenging conventional robotics paradigms, and making robotics more accessible, useful, and integrated into real-world applications and environments. So, with that being understood, let's look at their line of amazing robots and why they will someday make soldiers obsolete. LS3, also known as the Alpha Dog, was developed primarily as a robotic pack mule to carry heavy equipment for military squads over rough terrains, reducing the load for soldiers. It is a four-legged robot designed for stability across diverse landscapes and was built to haul up to 400 pounds of gear and enough fuel for a 20-mile mission lasting 24 hours. The LS3 can traverse rough terrains including rocky grounds, forests, and even snow, much like a real mule. And is equipped with sensors to follow a human leader, can navigate to designated locations, and can avoid obstacles. The Spot Mini is a four-legged robot with a sleek and lightweight build and is particularly effective for its capabilities in indoor navigation, object manipulation, and surveillance. It is capable of walking, trotting, and navigating diverse terrains and environments, including stairs. It also comes with an arm that can perform a variety of tasks from opening doors to handling objects. Spot Mini is equipped with sensors that allow it to navigate, avoid obstacles, and even follow predefined routes without human intervention. It is one of Boston Dynamics' more compact designs, weighing around 65 pounds. Spot Mini has been commercially available for various industrial, research, and commercial applications. Differing from the company's usual quadruped or bipedal designs, Handle is a two-wheeled robot with two arms. It's designed for material handling and can navigate warehouses, lift boxes, and even jump over obstacles with its unique form factor. Thanks to its wheel design, Handle can move swiftly, turn sharply, and even perform dynamic maneuvers like jumps. Equipped with custom arms, Handle can lift and transport boxes, stack them, and perform other material handling tasks. And despite its seemingly unstable design, Handle has an exceptional balance system, allowing it to navigate through tight spaces, handle slopes, and even resist external disturbances. The robot employs depth cameras for navigation and object detection, enabling it to locate, pick up, and move objects autonomously. While it can be used in various scenarios, Handle's design is particularly optimized for logistics and warehouse operations, making it valuable for industries focused on shipping, storage, and distribution. Atlas is a bipedal humanoid robot, representing one of the most advanced robotic designs in terms of human-like movement and agility. Originally developed as a research platform, Atlas showcases the potential of humanoid robots in navigating complex terrains and environments, performing tasks that require a human form factor. Atlas stands out from Boston Dynamics' other robots with its ability to walk, run, jump, and even execute acrobatic maneuvers like backflips. Atlas is the most likely testbed for a future robot soldier, but we'll come back to Atlas a little bit later. Given the increasing advancements of the robots Boston Dynamics is now producing, the company has looked at ethical programming to ensure it operates within margins additive to society. Ethical programming refers to the conscientious practice of designing, developing, and deploying software that adheres to moral principles and standards. It emphasizes the protection of user privacy, ensuring data security, promoting transparency and preventing biases in algorithms. Additionally, it stresses the importance of developers taking responsibility for their software's societal and environmental impacts. At its core, ethical programming aims to ensure that technology serves the greater good and avoids causing harm to individuals or to society. Ethical programming in robotics involves designing, developing, and implementing robotic systems that adhere to moral principles and respect human rights. This approach ensures that as robots become more integrated into daily life, they interact in ways that are beneficial, respectful, and prevent unintended negative consequences for individuals and society. I said I'd get back to Atlas, and so here we are. Without a doubt, Atlas is the robot in BD's stable that is most suited to replacing soldiers, and when DARPA invests in the project, the US government agency responsible for the development of emerging technologies for use by the military, then you know there's a real possibility. The Atlas robot, with its humanoid design, boasts agility and mobility that allows it to navigate complex terrains similar to humans, making it potentially suitable for military scenarios. Its advanced autonomous capabilities, coupled with an array of sensors, mean it can operate in hazardous conditions without constant human intervention, thereby reducing risks to human lives. Atlas can also consistently perform tasks without experiencing fatigue or emotional stress, offering a level of operational steadiness that might be challenging to achieve with human soldiers. The combination of mechanical dexterity and an advanced AI brain will inevitably enable Atlas to make soldiers obsolete. There are recognized to be three types of robots in terms of design and function. The automatic robot is a machine designed to perform tasks relying on predefined programming or algorithms to execute its operations and typically requiring human inputs and control. These robots are typically set to conduct specific actions or sequences based on certain conditions or inputs. They lack the ability to adapt to new situations or learn from their environments, unless those capabilities are explicitly programmed into them. Common examples of automatic robots include industrial robots on assembly lines, which repeatedly perform the same tasks, such as welding or painting, based on their programmed instructions. And for military purposes, automatic robots are already being used, for example, as EOD robots that neutralize bomb threats. The automated robot typically follows set patterns and routines based on specific conditions or inputs. Automated robots can be programmed to identify enemy forces in a particular location, or have their paths to the enemy camps processed into their navigation systems. Automated robots are already used in the military, such as pre-programmed reconnaissance drones that fly without human input. And finally, the autonomous robot is where the debate around intelligent military use hinges, as these are the robots that are able to make choices between different options, even though they are still constrained by their programming. They can exercise a high level of judgment and logic using high-level artificial intelligence, which will eventually make soldiers obsolete. The final form of Boston Dynamics robot will fall into this category of robots. And given the capabilities these robots bring, it is easy to see why militaries around the world would be keen to deploy robots like this en masse to minimize military casualties and to make missions quicker and more effective. There are quite a few challenges to overcome with autonomous robots to replace soldiers, including ethical and legal. And it will be important to ensure we avoid a Terminator-like scenario where the robots turn on us. However, the future use of advanced robotics in the military to replace soldiers is an interesting one. And it will be fascinating to see how Boston Dynamics rises to this challenge to keep us glued to social media to see the newest iterations of their most fabulous robots.